In our lesson today, we're going to have more practice adding with signed numbers, and we're going to start with a review of what we learned in the last lesson, okay? In the last lesson, we saw that if the numbers that you are adding have the same sign, just keep track of how many positives or negatives you have. So in example number 1, in A, B, and C, we're going to find each sum. In A, we have 15 plus 8. Both of my numbers are positive, so all I have to do is count how many total positive numbers I have. 15 plus 8 is 23, so the answer here is positive 23. In letter B, we have negative 5 plus negative 10. Both of my numbers are negative this time, so we're just going to count how many negatives there are. 5 plus 10 is 15, and they're all negative, so my answer here is going to be negative 15. In letter C, I have negative 12 plus negative 7. Again, both of my numbers are negative, so I'm just going to count how many negatives there are. 12 plus 7 is 19, so negative 12 plus negative 7 is negative 19. In the last lesson, we also learned about zero-sum pairs and created diagrams to help us add positive and negative numbers together. This process is good to use if the numbers are small integers. If the numbers are large and/or contain fractions or decimals, then knowing the number's absolute value will help us find the sum. And so we need to remember what absolute value is. Absolute value represents a number's distance from zero. Okay? We use a bar notation to represent absolute value. So a number inside of the bars means absolute value. This means the absolute value of negative 3. In example 2, we're going to find the absolute value of each number below. So in letter A, okay, the number inside of the bars is negative 13. This means to find the absolute value of negative 13. And again, all we're trying to do is figure out how far away is this number from 0. Well, negative 13 is 13 units to the left of 0, so the absolute value of negative 13 is 13. In letter B, we're looking for the absolute value of 9. 9 is 9 units to the right of 0, so the absolute value of 9 is 9. Okay, and in letter C, we're looking for the absolute value of negative 8 and 25 hundredths. Negative 8 and 25 hundredths is 8 and 25 hundredths units to the left of 0, so the absolute value of negative 8 and 25 hundredths is 8 and 25 hundredths. Notice in all the examples, the absolute value comes out to be a positive number because, again, absolute value is a number's distance from 0, and distance cannot be negative. So now that we've reviewed absolute value, let's learn how absolute value can help us add numbers when the signs are different. We're going to think about the problem negative 66 plus 42. I want to first know, will the answer to this question be a positive number or a negative number? And in order to figure that out, I'm going to think about the absolute value of the two numbers in the problem. I've got negative 66 and I've got 42. Okay? The sign of the sum depends on which number has the greater absolute value. In this example, negative 66 has a greater absolute value. The absolute value of negative 66 is 66. The absolute value of 42 is 42. Since the negative number has the greater absolute value, my sum will be negative. So let's write that down. The sum will be negative. Okay, because negative 66 has a greater absolute value. Negative 66 has a greater absolute value. Okay, so if we compare the absolute values, the absolute value of negative 66 is greater than the absolute value of 42. So I know my answer is going to be a negative number. In letter B, we're going to find that sum, and again, remember from last class, if the two numbers that you're working with have different signs, then you have to relate that to a subtraction problem in order to help you figure out what the answer is going to be. So I'm going to take 66 and I'm going to subtract 42. 6 minus 2 is 4. 6 minus 4 is 2. So I know that negative 66 plus 42 is equal to negative 24. Okay, again, the negative number had the greater absolute value, and then I subtract these two absolute values to get the number portion. In example 4, we're going to find the sum of each problem below. In letter A, we have 29 plus negative 28. Again, when the signs are different, I have to figure out if my answer is going to be positive or negative, and I'm going to do that by looking at which number has the greater absolute value. In this example, positive 29 has a greater absolute value than negative 28, so I know my answer will be a positive number. And then remember, when the signs are different, you have to subtract the absolute values in order to get your answer. 29 minus 28 is equal to 1. And again, it's going to be positive 1 because the positive number has the greater absolute value. In letter B, we have negative 21 plus 9. So again, looking at the numbers, the number with the greater absolute value in this example happens to be negative 21, so I know my answer is going to be negative. And now to figure out what the number part is, again, these are different signs, so I'm going to subtract. 21 minus 9 is equal to 12. And so I know that negative 21 plus 9 is equal to negative 12. In example C, we have 350 plus negative 400. The number with the greater absolute value is negative 400, so my answer is going to be negative. And then because these have different signs, I'm going to subtract the absolute values. 400 minus 350 is 50. So the answer in this case, 350 plus negative 400 is negative 50. Okay, so here are the main ideas. These are the rules for adding any two rational numbers. If both of the numbers have the same sign, so they're either both positive or they're both negative, you're going to keep the sign and you're going to add the absolute values of the numbers. But if the numbers have different signs, like in these examples that we just did, then you're going to keep the sign of the number with the greater absolute value, and then you're going to subtract the absolute value of the numbers to get the number portion of your answer. So far we've had a lot of good practice with integers, and now we're going to practice adding signed fractions and decimals. And we're going to start by looking at fractions. These are the rules for adding fractions. Remember that in order to add fractions, you must have common denominators. Okay, remember that the denominator is the bottom part of the fraction. The denominators have to be the same whenever you want to add fractions. And then you just need to use the same rules for adding integers. Remember, we just said if the signs are the same, we're going to add the absolute values, and keep the sign. Okay, but if the numbers have different signs, we're going to subtract the absolute values, and this time we're going to keep the sign of the number with the greater absolute value. Whichever number has the greater absolute value, that's going to be the sign of your answer. So let's practice that underneath. In example 5, find the sum of each problem below. In letter A, we have 4/7 plus negative 3/5. These are different signs, so I'm going to be using this rule here. I need to subtract the absolute values. I need to keep the sign of the number with the greater absolute value. Also keep in mind that the denominators are different. I have to come up with a common denominator. If I'm working with sevenths and fifths, a good common denominator is going to be 35. So I'm going to change each of these fractions into an equivalent fraction where the denominator is 35. Okay, well, 7 times 5 gets me the 35, so I'll do 4 times 5 in the numerator, and that's going to equal 20 35ths. 5 times 7 gets me the 35, so 3 times 7 is going to be 21, making this fraction now negative 21 35ths. Okay, now I can figure out the sign of my answer based off of the absolute value. The absolute value of negative 21 35ths is bigger than the absolute value of 20 35ths, so I know my answer here is going to be negative. Let me put my negative symbol. And now since they're different signs, I'm going to subtract the absolute values. Okay, well, 21 35ths minus 20 35ths is equal to 1 35th. And so I know my answer is going to be negative 1 35th. In example B, I have negative 2/3 plus negative 1/6. Both of the signs are the same, so I'm going to use this rule, add the absolute values and keep the sign. So since they're both negative, I'm going to keep my negative symbol. And now I need to get a common denominator, thirds and sixths. A good common denominator is going to be sixths. So I'm going to make that a 6, keep my negative symbol, plus I can keep negative 1/6 the same. Okay, 3 times 2 is 6, so 2 times 2 is 4. So we have negative 4/6 plus negative 1/6. I add them together, and that gives me negative 5/6. In the last example, notice here that we have mixed numbers, 1 7/8 plus negative 3 1/2. I'm going to change these into single fractions first. 1 7/8 is equivalent to 15/8 plus negative 3 1/2 is equal to negative 7/2. Now I need to get common denominators, eighths and halves. I'm going to use eighths, so I'll keep 15/8 plus negative something eighths. 2 times 4 is 8, so 7 times 4 is 28. Now I can compare the absolute values. Negative 28/8 has the bigger absolute value, so I know my answer is negative. And again, when they're different signs, I'm going to subtract the absolute values. 28/8 minus 15/8 is going to be 13/8, so this is negative 13/8. And now if I make this a mixed number again, 8 goes into 13 once with 5/8 left over. So the final answer here is negative 1 5/8. We also need to review how to add decimals together. Remember that when you're adding decimals, you need to line up the decimal places. Okay, this makes sure that you add whole numbers to whole numbers, tenths places to tenths places, hundredths to hundredths, etc. Okay, line up those decimal places. When you're adding decimals, if you have any empty spaces, you're going to fill it in with a 0 to make sure that your decimal places line up. Okay, and then remember, if the signs are different, we're technically going to do a subtraction. So when subtracting decimals, write the number with the greater absolute value, the number with the greatest absolute value on top. So let's practice that. Letter A, negative 4 38/100ths plus negative 9,213 10,000ths. Both of my numbers are negative. They're the same sign, so my answer is going to be negative. And now we just add the absolute values together. So it's 4 38/100ths, 0 9213. I'm going to add these together. I have 2 empty spaces to fill in with a 0. 0 plus 3 is 3. 0 plus 1 is 1. 8 plus 2 is 10. I carry a 1. 1 plus 3 is 4. 4 plus 9 is 13. I carry a 1. Don't forget your decimal point. 1 plus 4 is 5. So my answer here is going to be negative 5 3,013 10,000ths. In letter B, I have 2 different signs, 3 86/100ths plus negative 6 4/10ths. Negative 6 4/10ths has the greater absolute value, so I know my answer is negative. And now I need to subtract the absolute values. The number with the greater absolute value goes on top. So 6 4/10ths. And I'm going to subtract 3 86/100ths. I have to put a 0 above that 6. And now I subtract 0 minus 6. I can't do that, so I'm going to borrow, make the 0 a 10, make the 4 a 3. 10 minus 6 is 4. 3 minus 8, again, we're going to have to borrow, make it a 13, make that 6 a 5. 13 minus 8 is 5. Bring your decimal point down. 5 minus 3 is 2. So we get an answer here of negative 2 54/100ths. Okay. Letter C, again, they're different signs. My positive number has the greater absolute value. I'm going to subtract again because they're different signs. And that's a 4, a 1, a 0. we get 144 thousandths.